Good morning, everyone. This is Rajesh from BAC IT department of SNS, Dr. SNS Rajalakshmi College of Arts and Science. So today I'm going to talk about mitigation strategies, in which we are going to see about recursion. So in mitigation strategies, there are iterative solutions, tail recursion optimization, increased stack size, and problem transformation. So in iterative solution for problems that can be solved iteratively, like factorial Fibonacci and etc., an iterative solution is generally performed to avoid stack overflow risk, as iterative solutions typically use a constant amount of stack space. So next one is the tail recursion optimization, that is TCO. Some compilers can optimize tail recursive functions, such as where the recursive call is the last operation in the function, into iterative code, effectively eliminating the stack growth. However, C compiler are not guaranteed to perform TCO. So increase the stack size. On some operating systems, the default stack size can be increased, but this is a system level change and not portable solution for the code itself. Problem transformations. For every deep recursion, considering breakdown the problem or using dynamic programming techniques to store immediately results and avoid redundant calculations, which can also reduce recursion depth. So for example, here we are going to see about evaluate the recursion and versus iteration calculating Fibonacci series, so which is placed in lead code also. The Fibonacci sequence defines as f of 0 equal to 0 and f of 1 is equal to 1 and f of n equal to n minus 1 plus n minus 2 for n is greater than 1. So recursive approach is simply, but the given statements are long Fibonacci recursive int n within bracket, if n is less than or equal to 1, the condition satisfies, then it returns 0, otherwise it returns to Fibonacci recursive n minus 1 plus Fibonacci recursive n minus 2. Okay, this is the snippet code for the Fibonacci series using recursive approach. So in readability and elegance, directly mirrors the mathematical definition, making the code concise and easy to understand for those familiar with the recursion. So extremely efficient redundant calculations are. This is a naive recursive approach suffers from exponential time complexity, that is the order of 2n. This is because it recalculates the same Fibonacci numbers multiple times. So for example, recursive of 5 calls the recursive of 4, 3, and then again 4 calls and 3 calls and 2 calls, leading to multiple completing each number twice. This will cause a major drawback in time complexity. The stack overflow risk are for even more moderately large n. The deep recursion can easily lead to a stack overflow due to the large number of stack frames. That's why we have to go for long Fibonacci series data type. So the iterative approach is given as a long Fibonacci iterative int n is a function created for Fibonacci. So similar to the Fibonacci for recursive also, we give if n is less than or equal to condition, then it returns 0, otherwise it go to long a equal to 0, long b equal to 1, long result. So for this int I is initiated in for loop and it is given as 2 and I is less than or equal to n. Then we go for increment part. The result equal to a plus b and a equal to b and b is equal to result. So and then we finally, after the for loop is completed, we return the result value. So in this flow efficiency has a linear time complexity, that is order of n is performed, but in recursive function we use order of 2n time complexity. So it calculates each Fibonacci number only once. So and constant memory uses a constant amount of memory, it is order of 1 regardless of n, as if only needs a few variables to store the previous two numbers, and there is no stack growth also. No stack overflow risks are initiated, eliminates the risk of stack overflow. So this is how we calculate through iterative methods. The conclusion of this statement is calculating Fibonacci series numbers, the iterative approach is overwhelmingly superior in terms of performance and the time and memory, and robustness, no stack overflow risk. The naive recursive approach is highly inefficient and should generally be avoided for the problem due to the exponential time complexity and stack overflow potential. While recursion can be made more efficient using memoization or dynamic programming, which is essentially transform it into an iterative approach by storing results. The direct iterative solution is the most straightforward and efficient for this specific problem. So thank you for your support, and let me consider the stop.